We want to solve the system of three equations with three unknowns using the method of addition, also referred to as the method of elimination. Recall, when solving this type of system, there are three possible outcomes. We could have one solution as an ordered triple, we can have no solution, as well as infinite solutions. Going back to our system, let's go ahead and label them to keep things organized. We'll label the equations A, B, and C. Analyzing the system, notice equation C only contains the variables x and z, which means if we add equations A and B and eliminate y, we'll have a second equation in terms of x and z, and then we can use that equation in equation C and solve that as a system to determine the solution. Analyzing the y terms in equations A and B, notice they're already opposites, which is what we want in order to eliminate the y terms when adding the two equations together. Recall, this is not always the case. Sometimes we have to multiply one or both equations by a constant to get particular variable terms to be opposites. So again, for our first step, we will add equations A and B. And again, this will eliminate the y terms because the y terms are opposites. So adding the equations, we have 2x plus x, which is 3x, and then y plus negative y is 0, and then negative 3z plus z is negative 2z, giving us minus 2z equals 0 plus 0, which is 0. Let's call the resulting equation equation D. So now we'll take equation D and equation C and solve those equations as a system of two equations and two unknowns. Notice in this case, though, the two equations are the same, and if we try to eliminate the x terms or y terms, we want them to be opposites, and therefore we would multiply either equation D or equation C by negative 1. Let's go ahead and multiply equation D by negative 1 and then add equation C. So negative 1 times equation D is negative 3x plus 2z equals 0, and equation C remains the same. And notice if we add the equations together, we have 0 plus 0 equals 0. The result is 0 equals 0. So whenever the variable terms simplify out, the resulting equation will always be true or always be false. In this case, 0 equals 0 is always true. This indicates the system has infinite solutions. And we'll look at this graphically in just a moment. Sometimes when solving this type of system, we can stop by stating there are infinite solutions. Other times, though, we're asked to express x, y, and z in terms of a new variable, for example, the variable t, where t is any real number. And this actually gives much more information because it gives a relationship among x, y, and z. For example, if we go back to either equation D or equation C and solve for x, we begin with 3x minus 2z equals 0. We would add 2z to both sides, which gives us 3x equals 2z, and then divide both sides by 3. Simplifying, we have x equals 2/3 z. So for example, if we let z equal t, where t is any real number, we could also express the infinite solutions as an ordered triple in terms of t. So we could also express the infinite solutions by letting, again, z equal t. So the third coordinate would be t, any real number. And if z is equal to t, notice we could express x as x equals 2/3 t. And then to express y in terms of t, we would have to go back to either equation A or B, substitute 2/3 t for x and t for z, and solve for y. Let's do this by using equation B. So using x minus y plus z equals 0, we substitute 2/3 t for x, t for z. Solving for y, we will add y to both sides, which gives us a y on the right, and then we have 2/3 t plus t, or 2/3 t plus 3/3 t, which gives us y equals 5/3 t. So again, sometimes you may be asked to express infinite solutions as an order triple in terms of a new variable, in this case t. In either case, the system has infinite solutions, which we will now verify by analyzing the graph. Recall, each equation gives a plane in space. So here we have the three planes in space. Because there are infinite solutions, there are an infinite number of lines on all three planes. Notice the three planes intersect in the red line, and we know a line has an infinite number of points. So our graph does verify the system has an infinite number of solutions. I hope you found this helpful.